Well, hello, geometry class. So today we're going to be talking about section 4.3, using congruent triangles. And this is where that funny mnemonic Cpctc is going to come in, okay? So let's remember that Cpctc, it stands for corresponding parts in congruent triangles are congruent. Now, in order to use Cpctc, the triangles must be congruent. So you have to prove that the triangles are congruent first, and then you're going to be able to do other things with Cpctc. So we're going to use what we know by proving triangles congruent using SAS, SSS, and ASA, and do other things. Okay, so here's a quick example. We're given that QR is congruent to RS, and we're given that angle 2 equals angle 1. Now, I also noticed that there's a reflexive side, so I'm going to put that in. So is triangle QRT, is it congruent to triangle SRT? Well, if you look, we've got a side to a side, an angle to an angle, and a side to a side, so they would be congruent. The answer would be yes, because of side, angle, side. All right, so now that we've proved the triangles are congruent, could we say that QT is congruent to ST? Well, if these two triangles are congruent, I'm going to put a dot in each one, then QT is congruent to ST, and the reason would be because of corresponding parts of congruent triangles are congruent, Cpctc, okay? So sometimes we're going to be asked to use congruent triangles to prove other things. Okay? We could be proving angles and sides congruent from the congruent triangles, and then using those angles and sides to prove parallel lines, midpoints, and other angles or segments congruent, or additional triangles congruent. All right, so let me show you what I mean. Now, on the next page, I want you to actually cross this one out. There's an error in that, but we're going to go to a proof, okay? So at the bottom of the second page, you'll see there's an example. PR bisects QPS, and PQ is congruent to PS. I want to prove that angle Q is congruent to angle S. Well, this is a great place to prove the triangles congruent first, and then prove the angles congruent by Cpctc. Why? Well, because I have two triangles that I see, and I know that that's a method for proving angles congruent. All right, so first we make our note, PR bisects angle QPS. So that's these two angles being bisected. So I'm going to put a 1 and a 2, and I'm going to mark them congruent to each other. I just think that's going to be easier. And then it says PQ congruent to QS. Okay, so I marked that. And then I see that reflexive side. So wow, I already see that I can prove the triangles congruent by SAS. S-A-S. All right, and if the triangles are congruent, then these angles Q and S are congruent by Cpctc. All right, so let's get that all together. So first we get our given. I'm going to put PQ, I'm going to put the side first, is congruent to PS. And that's a side. So there's my one congruent statement I need. That's given. And I also am going to put PR bisects angle QPS. Now that is not a congruence statement, so I have to make one. Based on PR bisecting angle QPS, we said that angle 1 was congruent to angle 2. Hopefully you're seeing now that's because of the definition of an angle bisector. As a reminder, you can get the which definition from the words used in the given, in that word bisect. All right, then we have to add our reflexive side because that's an angle, and I need one more piece. I need that third side I added to it, which was the reflexive side. So I can say PR is congruent to PR. And again, if it's a reflexive side, the reason's going to be reflexive, like we talked about in class. All right, and that's my side. So I have my three parts. I'm going to check. I have one congruent statement, another congruent statement, another congruent statement. So I'm ready to prove the triangle congruency. Now, this is where you guys have to be really careful because we could all actually write this different. The first one doesn't matter. So I'm just going to say triangle QPR. But remember, you have to follow the correspondence. And if I say QPR, I went through one hash mark and then the two. So I have to follow that same order. So it would be SPR. Now, you could have written that like RPQ to RPS, but that's up to you. And again, the reason would be side, angle, side. Okay, so that's what we were doing yesterday. Now we're going to take that one and sometimes two steps further. So now, because the triangles are congruent, we can say that Q is congruent to S. Look, they correspond. So angle Q is congruent to angle S because of Cpctc. Okay, so that's how you use congruent triangles to prove other angles congruent. Now, let's take that one step further. Okay? All right, so now we're going to prove congruent triangles to prove congruent segments to actually prove midpoint. Okay? So this takes, there's going to be two additional steps from the congruent triangle part. Okay? So we got to pay close attention. All right, let's see if we can prove how we can prove these triangles congruent. We see that 1 equals 2. We see that 3 equals 4. And I see a reflexive side. So it appears that I can prove this triangle congruent to this triangle by angle, side, angle. The side is in between those two angles. So I'm going to prove the triangle congruence first. All right, so I've got angle 3, the measure of angle 3 equals the measure of angle 4. That's an angle. And the measure of angle 1 is equal to the measure of angle 2. That's another angle. And I have to add that, and that's given. Okay, that's two, but I got to add that reflexive side because all reflexes have to be added. So that is LM. Segment LM is congruent to segment LM. That's a side. And so that would be reflexive. All right, so the triangles are congruent. So triangle JML would be congruent to KML. Triangle KML. Because of angle, side, angle. All right, so now we've got the triangles to prove congruent, but we're trying to prove midpoint. Well, the only way you can prove midpoint would be if, and that's the goal I want, would be to prove that JM is congruent to MK. If I can say that statement by Cpctc, then M is the midpoint by the definition of a midpoint. All right, so let's put that together. So here we go. We're going to say, based on the congruence, the triangle congruence, that JM is congruent to KM or MK. And that would be because of Cpctc. And then therefore, M is the midpoint of JK. And that would be what we've been doing all year, the definition of a midpoint. Now I need you to really pay close attention. You cannot prove midpoint using Cpctc. This step was critical. You had to prove angles and sides congruent with Cpctc. Cpctc only allows you to prove angles and sides congruent. Angles and sides congruent. Okay? All right, one more. M is the midpoint of AB, and we're trying to prove that the lines are parallel. Okay, so I see two triangles. This is one of those hourglass proofs we talked about. The hourglass is just tilted. All right, so we've got M is the midpoint of AB and CD. Okay, so here there's a B missing, so let's put the B there. So M is the midpoint, so AM is congruent to MB, M is the midpoint of CD, so DM is congruent to MC. All right, great. I've got 2 sets of congruencies, so now I go to my list. Do I see any reflexive sides? No. Do I see any vertical angles? I do. So there, I'm going to put a 1 and a 2, and there are my vertical angles. So it appears that I can prove, yes, I can prove these triangles congruent using the side angle side postulate. So I got to get that done. So I always get to the triangle congruence. At a minimum, get to the triangle congruence. So I've got my given. I can then say that AM is congruent to MB. Is congruent to MB. That's a side. Because of the definition of a midpoint. And I can actually put the other part in that same step. So DM is congruent to MC. That is also a side. And again, that's the definition of a midpoint. All right, that's 2 congruent pieces. I need a third. So that's where I'm going to add those vertical angles. So angle 1 congruent to angle 2. That's an angle. And that would be because of the, hopefully you said out loud, vertical angle theorem. Vertical angles are congruent, are equal, right? All right, so that's enough to prove the triangle congruency. So triangle AMD is congruent to triangle BMC. Okay, so now make sure on that one that you follow order, okay? So the order there, AMD would have to go BMC. Okay, now if I want to prove the lines are parallel, I need to either prove alternate interior angles are congruent or corresponding angles are congruent. In looking at this hourglass proof, remember, if we can prove the angles are congruent, if I can prove angle A and angle B are congruent, well, that forms the Z. So then the lines would be parallel by the alternate interior angle theorem converse. Well, based on the triangle congruency and side angle side, okay, we can say then that angle A is congruent to angle B because of Cpctc, okay, Cpctc. And if A is congruent to B, those are alternate interior angles, that would make the top of the Z and the bottom of the Z parallel. So AD is parallel to BC because of the alternate interior angle theorem converse. Okay, this proof, guys, is one you're going to see a lot. I could give you lots of different given information to prove the triangle congruent, but these last 2 steps, again, remember, from the triangle congruence, there's going to be at a minimum 2 steps. Angle congruency by Cpctc, and then something else, whether it be proving parallel lines or midpoint or segment bisector like we did in the last one. All right, hopefully that was a helpful lesson, and I will see you tomorrow in class. Have a great night.